Okay, I'm going to start off doing a little bit of a review of some of the basics, just in case. So, one of the first Bohr diagrams we did when we started this was calcium-42. So I gave you this information, which is an isotope notation, where the name or symbol is going to tell you how many protons you have. For calcium, if you look it up on the periodic table from classroom, the blue number in the upper corner is 20. It means it has 20 protons, which is where we get this. So P equals 20. 42 is the mass number. Okay, and remembering back to our atomic calculations that we did recently, the mass number is the number of protons plus the number of neutrons. So if we know we have 20 protons, and we know there's 42 total particles in the nucleus, then we can subtract those two numbers to get the number of neutrons. So 42 minus 20 gives us 22 neutrons. Then we have to do our electrons. Now, for starters, everything we've been doing is a neutral atom. Neutral means there's no charge, which means the electrons are going to be the same as the number of protons. We have to have the same number of both. So we have to have 20 electrons. And so using this table, which is on the last page of the Unit 1 notes, we can tell how many electrons each circle or each orbital of the Bohr diagram can hold. So the first one can hold 2. So we've got 2 in the first. Then 8, 8, and 18. So we've got 8 in the second, 8 in the third. But that's 18 electrons right there. Between the first 3 shells, we've already accounted for 18. So we don't need to add another 18 electrons to the outer energy level. We only need 2. So we have only 2 in the outer shell. Now, there is another way that I can give you this mass number. I can say, do the most common isotope. Now, the most common isotope is something that you pull off of the periodic table. So if you look at the periodic table for calcium, there's a red number in the bottom of the calcium cell. And that number is 40.078. That's the average atomic mass. To get the most common isotope, you round the average atomic mass. So 40 point, what did I say, 079? 078. This is the number we use to round. 0 makes this stay the same, so we just drop this. So 40 is the mass number for the most common isotope of calcium. So that's another way that I can give you the mass number without actually telling you what the number is. But you have to have a periodic table in order to do that. So from there, let's do a Bohr diagram for the most common isotope of nitrogen. So nitrogen has an average atomic mass of 14.0067. So because this is a 0 again, we just drop all that. 14 is going to be our mass number. So because it's nitrogen, we know it has 7 protons. So P equals 7. And since our mass number is 14, we know that N is also going to be 7. Then we need 7 electrons. 2 go into the first shell. And then the next shell can hold 8, but we're only going to put 5 in it because we only need 7 total. Okay, so that would be using the most common isotope of nitrogen. That would be how you would do that. We're going to do one more example with most common isotope. We're going to do the most common isotope of boron. which is 2 over from nitrogen. And I'm realizing that this is backwards, so I'm pointing in the wrong direction from this, I think. But we're going to roll with it. It's element 5. So boron's most common isotope, or boron's average atomic mass, is 10.812. So if we round that, we're using the 8 this time. The 8 is going to cause this to go up. So this is going to be 11 for our mass number instead of just 10 because the 8 makes the 10 round up. Now, protons, same thing. Atomic number is 5 for boron, blue number in the top corner. So we know P equals 5. That's too close. And since our mass number is 11, 11 minus 5 is going to give us neutrons 6. Okay, so that's our nucleus. Now we just need to do electrons. So we need 5 total electrons. So 2 in the first energy level. And then we need 3 more to get our 5. So that's how most common isotope works. It's just another way for me to give you the mass number without actually telling you what the number is. So next, let's talk about most common ion, which is what we did yesterday. Most common ion is when, well, an ion, I should start with that. An ion is a charged atom, an atom that has a charge. Every atom has an ion that it most readily ionizes to, or its most common ion. And we can figure that out using what's called the octet rule, which is not in your notes, so you might have to write this down. Okay, the octet rule says that every atom wants a full outer shell. And it will gain or lose electrons to get a full outer shell. A full outer shell is going to consist of 8 valence electrons. So even though all of these shells can hold more than 8 electrons, only 8 of them can be valence electrons. Now, valence electrons are bonding electrons. They're the electrons that form bonds when atoms connect to form a molecule or a compound. And valence electrons have to be part of the S subshell or P subshell, which is something we'll talk about when we get to electron configuration. Now, what that boils down to for most common ion is this. When you look at a Bohr diagram, you can see, looking at it, that there are 5 electrons in the outermost shell. So it has 5 valence electrons currently. That shell will hold 8 electrons. And so what that atom wants to do is it wants to get a full outer shell. It can either do that by gaining 3 more electrons, which will bring it up to 8 in its outer shell, or it can lose the 5 that it's got and go down to this shell, which is already full. So it's got 2 options. Atoms always take the path of least resistance. Right? So since this atom has 5 in its outer shell, it would have to lose 5 or gain 3. Well, 3 is less than 5, so it's going to gain the 3. So we would add 3 electrons to this shell. But that causes a problem because now this atom does not have the same number of protons as it does electrons. So since it has extra electrons, it's now an ion. It's going to have a charge, which we have to note in the corner here. The way you figure that out, you can either use the equation that we had before. The ionic charge is equal to protons minus electrons. Or you can logic your way through it. How many electrons did we add? Well, we added 3. So that's going to be the magnitude of the charge. That's the number. Is it going to be positive or negative? Well, do we we have more electrons, which are negative, or do we have more protons, which are positive? We have more electrons, so it's going to be -3. Or we can use this equation here. Ionic charge is protons minus electrons. We have 7 protons, and we have 10 electrons. So 7 minus 10 is -3. Both of those will give you the correct answer. So I'm going to give you a second. Pause this if you need to, and you try to figure out this one, and then I'll go through it. All right. I'm assuming you paused it and did it. Okay, so this atom has 3 electrons in its outermost shell. Since it's got 3, its 2 options are to either gain 5 or lose those 3. 3 is less than 5, as once again, and so it will lose these 3 electrons. We now have 5 protons, which are positive, and only 2 negative electrons, so this is going to be a +3 charge. The homework assignment for class yesterday was to draw the Bohr diagram for the most common isotope and most common ion for every element in period 2. These are 2 of them, so that's only 6 more. So draw those out. If you can, take a picture of them and email them to me, and I can check them for you and let you know.